Have you ever noticed after a long, heavy rain that the ground just seems to stop soaking up water, and instead, puddles from everywhere, and water starts flowing over the surface? It is a common phenomenon that holds significant implications for our environment. Saturated soil produces surface runoff because its pore spaces are entirely filled with water, preventing any further infiltration into the ground. Once the soil reaches this point, any additional rainfall has nowhere to go but to flow across the surface. To understand this, we need to consider the soil's infiltration capacity, which is the maximum rate at which water can enter the soil. Initially, dry soil has many open pore spaces between its particles. These spaces act like tiny reservoirs, drawing water in through gravity and capillary action. As rain continues, these pores fill up. When all the available pore spaces are occupied by water, the soil is said to be saturated. At this point, the infiltration rate drops dramatically, often approaching zero, because there is no more room for water to physically enter the soil matrix. Any rainfall arriving at the surface then becomes overland flow, also known as saturation excess runoff. This understanding is crucial for managing water resources and predicting flood risks. For example, knowing the antecedent moisture conditions, which refers to the wetness of the soil before a rain event, allows hydrologists to better forecast how much rainfall might turn into runoff and contribute to river flows or local flooding. It also helps in designing effective drainage systems and managing agricultural lands to prevent erosion and nutrient loss caused by excessive surface flow. Understanding the mechanisms of runoff generation from saturated soils is a cornerstone of effective watershed management. This mechanism, known as saturation excess runoff, is distinct from infiltration excess runoff, often called Hortonian flow, which occurs when rainfall intensity simply exceeds the soil's maximum infiltration rate, even if the soil is not yet fully saturated. While Hortonian flow is more common in arid regions or on compacted surfaces, saturation excess runoff is frequently observed in humid environments with high water tables or after prolonged periods of rain, making it a critical consideration in many hydrological models and studies. Identifying which type of runoff generation is dominant in a given area greatly improves flood prediction accuracy. Ultimately, recognizing why saturated soil generates runoff provides a foundational insight into the hydrological cycle. This knowledge enables us to make more informed decisions about land use, urban planning, and infrastructure development, all of which are essential for mitigating environmental damage and ensuring the sustainable management of our planet's precious water resources.
If you love learning about water, like, subscribe, and keep exploring with us.